Okay, we can discuss more at the end of class. Here we go. So, actually, somebody who come up and do the first one. Thanks. Yes, after you. Okay, but you gotta talk us through it loudly, clearly. Okay, tell us your thought process.
First thing I did was I noticed that they're all log fives. So it's gonna be, you can take one out and then it's gonna be the log five and then the rest. And then I took each of these, the numbers next to it, and I put them onto exponents or square roots. And so this is going to be x3 because the log's gone now. Okay, yeah. Anyway, so that's gonna be x3 minus, and if it's, I'm going to add all the pluses first because that goes on the top, and then you divide by the negatives, so, and then plus, or not times, I mean that's times, the square root of y, since this is the 1/2 power.
So you're saying that you can reorder addition and subtraction in any order you want.
Yeah.
That is true. So you're putting all your addition ones on top being multiplied. Very true. True.
And then all the subtraction ones right here, if the second power solution is v, these are vectors. And then third root of.
Okay, pause there. Okay. There you go. Okay, did everybody who got that? Raise your hand. Many people. Okay, awesome. You explained that perfectly. Good. Awesome, very good. All right. Anybody else want to come and do this one, please? Anybody? Wes?
Okay, so.
Okay, everybody listening, because a lot of people kind of struggle with this one. So listen to his thought process and then repeat it very quickly. So listen.
So working backwards, we're just going from there to there. So I go ln 3 times, and then x squared. So that would be 1/2 x, because we know a square root, and that can be put into the front. Y, and then that's a 4. And then since that's subtraction, addition. That's not really how I.
Perfect. That is true. Awesome. So, very good. That's exactly right. So he has x to the 1/2 power, pull the 1/2 in front, ln of x. When you multiply, you add, right? When you divide, then you subtract. Very good, Wes. Thank you. Questions on that, guys? We should be pretty quick at those. Okay, good. Okay, today we're doing my favorite of all favorites. It's solving logarithmic and exponential equations. The nice thing is there's like nothing to learn. We've learned everything we need to know. We just start going for it. So solving all types of equations, guys, you get the variable all by itself and then solve for the variable. So these are the step-by-step instructions on how to solve logs or exponentials, give or take. Every problem is going to be a little different. It's just using algebra though. That's why I love this, is because I love algebra. Now here's the thing, to solve these correctly, you can't make weird algebra mistakes and do weird things to things that you can't do. Okay, so our first step is get the log or exponential on one side of the equation. Listening, we're gonna try to get just one log or exponential all on one side of the equation. You might have to combine the logarithms if you have multiple logarithms using properties of logs. You only want one logarithm or one exponential on each side of the equation. Second, then you'll undo the log or undo the exponential by applying the inverse. If it's a log, you'll do the exponential inverse. If it's an exponential, you'll take the log of both sides. So you're undoing the log or exponential by applying the inverse. Then from there, you'll simply solve for x using algebra. So it's really that easy. Forrest, check your answer. I don't know why I didn't say it like that. So we're going to want to check our answers, especially when we start doing so much to these things, because it can introduce extraneous solutions. So really now it's just practicing and watching. I almost don't even know if you should take notes. You should just watch because you're going to have plenty of practice, but it's really up to you. But do you get what I'm saying? Every problem's different. You're going to watch and say, oh, I see what she's doing every time. Now I'm going to practice. Okay, so here we go. So first thing we are solving an exponential in this first example. So the first thing we do is isolate the exponential. Do you see how we have one exponential on this side of the equation and one on this side? So now you undo the exponential. How do you undo e? ln. So I'm not on. There we go. So we're going to ln both sides of the equation. ln and e cancel out. So we have negative x squared equals ln and e cancel out. Negative 3x minus 4. And now we simply have a quadratic to solve. So we solve quadratics by getting it set equal to 0. Here's my thought process. I want you thinking exactly on these to make your life easier. Isn't it best to have a quadratic that has positive x squared so that we can quick factor and solve by factoring? So let's bring x squared over. 0 is equal to x squared minus 3x minus 4. Let's solve by factoring. What multiplies to be negative 4 and adds up to be negative 3. A times c adds up to be b. Negative 4, positive 1. So this factors to b. We're not going to jump to conclusions because we're honor students. We're going to think. So our solutions are x is equal to 4 and x is equal to negative 1, correct? Let's check those. Everybody calculators. This is where I need you calculating. So let's check 4. So you'll go back to the original. E to the negative 4 squared. Now 4 was not, this negative is not squared. Looking at the problem. Equals E, and we could even just use our own hands of algebra here. Negative 3 times 4 minus 4. So we don't even really need a calculator. Look, that's e to the negative 16 equals e to the negative 16 when I plug in 4, isn't it? Guys? So that is the same thing. Do you see what I'm saying? So let's check. I'm going to check now for e equals negative 1. So that would be e, plugging it in here. Negative of negative 1 squared equals e to the negative 3 times negative 1 minus 4. So that's going to become e to the negative 1, isn't it? Equals e to the 3 minus 4 is negative 1. So both work, neither are extraneous. There's our two solutions. So we really should be checking them by hand if possible. We'll see. That's okay. You probably just typed it in wrong. Got it. Yeah, I'm sure that you just typed it in wrong. Okay, everybody, here we go. Solving the logarithmic and exponential equation. So this one's exponential, correct? First thing we've got to do is isolate the base 2, so that we can undo base 2. But do you guys understand that we need to get 2 all by itself first? So when we divide both sides by 3, guys, 2 to the x power equals what? 42 divided by 3. 14, perfect. Oops. Okay, so then from here you'd say to yourself, I'm trying to solve for x. It is up in an exponent. I want to use algebra to get x alone. We need to undo base 2. What undoes base 2? Log base 2 of both sides of the equation. So log to the base 2, log to the base 2. So over here, log to the base 2 and base 2 cancel out, x drops down. So x is equal to log to the base 2 of 14. Now you'd say from there, I can evaluate this 2 different ways. Change your base formula, which I'm going to do, or you could rewrite it as an exponential and see if you can evaluate it that way. Let's just use change your base formula. So isn't x equal to log of 14? Remember we learned this last time, putting it in base 10, divided by log of 2. Now understand, even if your calculator can do the base 2 for you, I have literally seen on the ACT these type of answers. Like this would be your answer. Final answer that. Multiple choice test. So if you didn't know how to, you know what I mean, change your base formula, you'd get it wrong, which you should be good. So now from there, type it in. What do we get? 3.8. Is it a much longer decimal than that? Yeah. Okay, so when we're checking it, we're going to want to use, so I want you to practice checking it. Ready? Keep that answer stored in your calculator, just like the last answer. So you'll type in your calculator 3 times 2 raised to the second answer, because you need the full decimal. You guys know what I'm talking about, right? Okay, you should check. Well, it will come out to be the original, should come out to be 42. Oh, you hit. It's the second name. Second subtraction sign? Negative sign. That's, yeah. Do you get 42? Do you? Okay, cool. Okay, next one, solve the log equation. So our first step is to isolate the exponential. So we're going to subtract 5 from both sides. Are we following still, people? E to the x equals, right? Guys? And then from there, we're saying x is up in the exponent. We need to get it down. We need to undo e. So we'll ln both sides. ln and e undo each other, so x is equal to ln of 55. That's a much prettier answer than a decimal answer, so I'm going to want to see both on the test. I'm going to want to see this, which is equal to which decimal? 4.00. Okay, cool. Yeah. This is an exact answer. This is a rounded answer. And you guys, we could check it. So you would type in calculator, second ln, which will give you E, then second answer, so that you have the full decimal, and then make sure you get out of the exponent, and then plus 5, hit enter. It should come out to be 60. Checking our answers is huge. Because then when you give me the test, you'll know I got 100% or I did not. Okay. So solve the log or exponential equation. So with this one, what would you suggest we do first? Good, add 4 to both sides. We're isolating the base. So we have 2 and then times 3 raised to the 2t minus 5 and then equals 15, right? Yeah. Next step, divide by, okay, watch what I would expect to see as work. So we have 3 raised to the 2t minus 5 equals 15 halves, which doesn't simplify. Leave it as 15 halves. Next step would be to good, log to the base 3, because we need to solve for t. It's stuck up in an exponent. Log to the base 3 of both sides. So let me show you what would be expected. 2t minus 5 equals log to the base 3 of 15 halves. True? Now what's my next step? Good, add 5 to both sides. You're good, I knew what you meant. And then what would you do? Divide both sides by 2. So t is equal to that, and then also the decimal answer. Okay, so see if you can type that in and get the right decimal. So let's think about how we're going to have to do this. For this piece right here, we're going to have to use change your base formula, right? Yeah. Hey, let's see if you can type it in right. I know you can do it. Log of 15 halves divided by log of 3 plus 5 divided by 2. 3.417 is what I got. Okay. Now I am going to know if I typed it in right by checking my answer every single time. So watch. We got to type in the full decimal. So I'm going to type in 2 parentheses 3 raised to the 2 times second answer. I've got to use parentheses up here like no other. So I'm going to show you how I'm typing into my calculator. And I might be using extra parentheses just to be careful. 2 times answer, that means 2 times answer, plus 5. Close it. And then I hit enter, and then I'm going to do, did I do minus 5? I did plus 5, dang nabbit. Minus 5 minus 4, and it comes out to be 11. Okay, awesome. So we did get it right. Even though that decimal seemed a little odd, it was right. Okay, this one is tricky. This one, even at first, kind of, I looked at it for a second and went, huh, what should I do to solve this one? That is a good thought. Here's a good thought. You could, but then here's the problem. If you brought E over this way, you can't undo, then you'd have, let me show you just so algebraically you can see what happened. Let's say you added 3e to the x over here. Now when you go to ln, you can't because there's a plus sign. You can't just ln a piece and ln that. Does that make sense? That's like breaking the forbidden rule. You can't just ln that. Okay, so that was a good thought, and then I would backtrack and say, okay, no, not going to tackle it that way. Now same thing, even if I brought the 2 over, we're in trouble because we have e and e split apart. Okay, so what we're going to do is, does anybody have any other ideas? Let's see if you can. We just tried, well, we could try that. Let me show you what would happen though. I like the ideas. So now when we go to take the ln, we're split by a subtraction sign, and we can't do it. But remember that it's putting them together, this is e's, this isn't ln's. Like we can't, you know what I mean? It's not, it would be a good idea if it was ln's, but these are e's. So this is how we would do it. Do you notice how this one is quadratic in form? Because technically we have e squared minus 3e plus 2. Quadratic in form, e squared minus 3e plus 2. So we're going to do a u substitution for quadratic in form. Do you remember back when we were solving these guys?
Yeah.
X squared minus 3, x to the 4th minus 3x squared plus 2. Quadratic in form, right? This is the same idea. It's quadratic in form. So we're going to go off to the side and say, let u equal e squared. Let u equal e to the x is what I meant to say, sorry. Let u equal e to the x. So what we really have here is e raised to the, e raised to the x squared, don't we? Raise the power to a power and you multiply, minus 3 e to the x plus 2 equals 0. So now let's replace all of our e to the x's with u's. So we have u squared minus 3u plus 2 equals 0. Now we can solve for u by factoring. So we would have u plus u minus 2. Sorry, let's do, I'm not going to jump because some of us. Well, it multiplies to be 2 and adds up to be negative 3. 1 times 2, negative, negative, right? So this factors to be u minus 1, u minus 2, thus u equals 1 and u equals 2. So that's u. So let's go put it in right up here. So we have this true statement here. We have 1, because u equals 1, equals e to the x. Now solve for x. So won't we ln both sides now? We're solving for x now. So we'll ln both sides to get x alone. ln and e undo each other. So ln of 1, which is what right away? Right away. What's the answer? 0. Good. That's literally Miss Summers came in and said, my calculus students can't tell me what ln of 1 is. What is it right away? 0, guys. Any base, any log to the of the 1 is 0, right? So we have ln of 1 equals x. So 0 equals x. Then we also have u is 2. So we have 2 equals e to the x. We need to undo e. So ln both sides. So x equals ln of 2. So let's check that. ln of 2 and 0. Here we go. You just type in, there's just an ln key on the left-hand side. I'm giving myself some room to check. Okay. So let's check 0. So we have e raised to the 2 times 0 minus 3 e to the 0 plus 2 equals 0. That would be our statement, right? So e to the 0 minus 3 e to the 0 plus 2 equals 0. So isn't that 1 minus 3 plus 2 equals 0? 1 minus 3, negative 2 plus 2 is 0. So doesn't 0 work? 0 works. I'm going to erase and check ln of 2. Let's just do the decimal for that one. Maybe. There's many ways we can do it, but. Or we could not. Well, we could check it many different ways. Do you want to use? Okay, let's do e raised to the 2 and then ln of 2, right? Minus 3. It's almost good to not, and then you have to really kind of think more. ln of 2 plus 2. Let's see what this simplifies to be. Feel like we're going to have to take this 2 and put it up here in the exponent, aren't we? E and then ln of 2 squared. Yeah? Okay, I'm sorry, I gotta give myself some room. And then minus 3 times e ln of 2. So won't e and ln undo each other?
Yeah.
So it's negative 3 times 2 plus 2 equals 0. Let's see. So right here, we have 4 minus 6 plus 2 equals 0. So that works too. So they're both solutions. ln of 2 was a solution.
So it's easier to use ln of 2 then?
No, it would have been easier to use the decimal, because then you would have just, not had to think. We had to use properties of exponents and stuff, so I wanted to push us a little bit. Okay. Okay, only a few more. I'm almost done. How do I solve this one? We're solving for x, so isolate ln, right? Then we'll do the what? E of both sides. ln and e undo each other, so x is equal to e to the third power. That's a pretty answer. Now give me the approximate decimal. 20.1. Perfect. Now type into your, make sure you use the full decimal. Type in ln of answer. Perfect. Comes out perfectly. So our answer was 20.1, that full decimal. So same thing here, right? You would do the e of both sides. So x is equal to e squared, which is a decimal. Okay, we're good. Okay, so last few. How would we solve this one? Yeah, base 3 both sides. Now look, log of base 3 and base 3 cancel out. 5x minus 1 equals x plus 7, and now it's just algebra, right? So 8 equals 4x, x equals 2. Easy. So now here's how you can really check it too. You don't even have to calculate it. Log the base 3 of 2, plug in here, so that's 10 minus 1, right? Log the base 3 of 9 equals, and then plug it in here, log the base 3 of 9, so it is definitely a true statement. Okay, solving. So everybody notice on this side of the equation, we have 2 logs to the base 6. So we need to put it into 1 log, right? So we would rewrite this as log to the base 6 of 3x plus 14 divided by 5, right? Equals log to the base 6 of 2x. Now we would solve for x. So we would need to undo log to the base 6. So we'd base 6 both sides. Base 6 log to the base 6 cancel out. 3x plus 14 over 5 equals 2x. Now solve for x. So when you multiply up, 3x plus 14 equals 10x, doesn't it?
Yeah.
Subtract 3x, 14 equals 7x, thus x equals 2. So it's just algebra. All of it's really just algebra. That's why it's so easy. Okay, a couple more. So our first step would be to do what? There's so many ways to solve this one. Subtract 5 from both sides. Very good. So we have 2 ln of x equals negative 1. What would you do next? Divide by 2, divide by 2. ln of x equals negative 1/2. Then what would you do? E both sides. ln and e undo each other. So x is equal to e to the negative 1/2 power. If it was a multiple choice test, or if you were going to be extra advanced, wouldn't you go this far? Let's see how advanced we can be. 1 over, yep, 1 over the square root of e. Is that an acceptable answer? Not quite, right? So it just depends on how far we want to go here. So we would rationalize. So x is equal to square root of e over e. This would be probably what you'd see on a multiple choice test as your final answer. Did you see how I got there? Okay. Okay, couple more. First step, divide by 2, right? So we have log to the base 5 of 3x equals 2. Then we would 5 both sides, base 5. 3x equals, and then divide by 3. So x is 25/3, right? Checking our answers. Now understand, if we have a negative answer and we want to plug it back in, won't it be an error? We can't have a negative inside of a log, right?
Yeah.
So just keep that in mind.
So what would you do?
It would just be no solution. Okay, we're almost done. I'm going to let you work. So look, 2 logarithms with addition. So we're going to put them together using properties of log. So log to the base 10, we don't need to write base 10, of 5x times x minus 1, right? When you add, you multiply, equals 2. Now understand this is all trapped inside the log. So we'll be base 10 both sides. Base 10 and log of the base 10 cancel out. So 5x squared, I'm distributing, minus 5x equals 100. And now it's a quadratic, 5x squared minus 5x minus 100 equals 0. We can solve by factoring, or we can factor out a 5. And then left is x squared minus x minus 25, right? Minus 20. But this won't hurt our solution, right? Like it won't affect our solution. So now we can quick factor it. So now we would do what multiplies to be negative equals 0. Well, so now the 5 won't affect our solution. So we could have what multiplies to be negative 20 and adds up to be negative 1. 4 times 5, negative 5, right? Factors to be x plus 4, x minus 5. So x is equal to negative 4, x is equal to 5. We better check them. Is negative 4 going to work right off the bat? No, look, 5 times negative 4 is log of negative 20. That's error. Like, you cannot have a negative of a log. So we would throw out negative 4, and then we would check 5, and it comes out all good. Everybody understand?
Yep.
5 was not extraneous. You could type it in. So it'll be log of 25 plus log of 4. Do you get 2? Let's check it. We better check it. Because it's base 10, so we can just type it into our calculator. Log of 25, it works? Perfect. So we would keep 5. Okay, last example of the day. You deposited $500 in an account that pays 6.75 interest compounded continuous. We just saw the keyword, compounded continuously. What formula? Y is equal to P times E raised to the RT. Okay, everybody watch. How long will it take to double your money? Well, first of all, okay, so our initial value was $500, so that's our put down amount, correct? E is just a number. Our rate is 6.75%, 0.0675. And then T is the time in the account. It says how long will it take to double? So we don't know time. We do know what it would be doubled. How much would it be? So 1,000. Now let's use algebra. So in regular, we just have them solved by graphing. Right? We just have them solved by graphing. Couldn't you graph this and see where they intersect? But where we're honors, let's do algebra. Divide by 500, right? 2 is equal to E raised to the 0.067t. Now I'm solving for t, so when my ln both sides, ln of 2 equals, ln and e undo each other, 0.0675, I left off the 5, 5t, so now when we divide by 0.0675. So t is alone, that would be our answer, and then you said 10.26 years.
No, I got. Yep.
Okay, perfect. Feels right to me. Cool, okay, the problems are, here's the thing, there's a lot of problems, but I'm giving you the rest of class, and honestly, here's the thing. The more you just practice, they were all pretty quick. The more you practice, the better prepared you are for tests, right? That's why I'm giving so many. So, it's 9 through 107 odds, and the only reason I assigned that many is because they're all just so great. And honestly, what if I just do it? Okay, awesome.